Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Let me introduce myself. My name is Zatnika Muhamad. My student ID 250512300017. On this occasion, I'm going to explain and compare the methodology section of two Elsevier journal articles that I have selected. Both papers were published in Results in Engineering, which is an Elsevier journal. The first article is titled Study Effect of Active Flux on Mechanical Properties of TIG Welding Process by Zainab Hussein Mohsen and colleagues. The second one is Overlapped Weld Bit Analysis on Dissimilar Diplex Stainless Steel 2507 and Inconel 625 using WAAM CMT process by G. Goguraj and G. Raja Murugan. Now, let's start with the first article. The study focused on how active flux materials, specifically silicon dioxide, manganese dioxide, and a 50-50 composite of both affect the mechanical properties of low-carbon steel welded using the TIG or tungsten inert gas welding process. In the experimental details section, the authors clearly describe the materials, equipment, and procedure they use. The material in the study was low-carbon steel plates, each measuring 200 by 100 by 6 mm. The flux powders of silicon dioxide and manganese dioxide were supplied from Vixanal, Germany. For the equipment, they used an ESAB Power TIG 160 welding machine, a 3 mm EWTH2 tungsten electrode, and argon gas flowing at 15 liters per minute as the shielding gas. They also use a 20 kN tensile testing machine and a TH715 digital hardness tester to measure mechanical performance. The procedure was quite systematic. Each steel plate was first polished and cleaned with acetone, then coated with a thin layer of flux paste made by mixing 1000 and 500 mg of powder with 1.5 mm of acetone. Welding was performed at 110 amperes of current, 12 volts, and a 6-second duration using direct current straight polarity. There were 3 experimental conditions, one without flux, one with single flux, and one with a mixed flux. Overall, this methodology is purely experimental, designed to compare how different active fluxes influence weld strength, hardness, and microstructural quality. Now moving on the second article. The study focused on dissimilar metal welding, where the researchers joined two different materials, duplex stainless steel 2507 and Inconel 625, using a modern process called wire arch additive manufacturing with cold metal transfer, or WAAM CMT. In the materials and methods section, the authors explain they use filler wires of both metals, each 1.2 mm in diameter, and stainless steel 304 plate as the substrate. As in the first article, argon gas with 99.99 purity was used as the shielding gas. The process was performed using a TPS 400i CMT welding machine, which was robotically controlled by an ABB arm. The setup allowed precise control of welding speed and overlap distance. In this experiment, the treble speed was constant at 120 mm per minute, while the current was varied at 140, 160, and 180 amperes. The weld bits were deposited with a 30 overlap, and the heat input was calculated using a standard equation based on voltage, current, and speed. Several analytical techniques were applied. They performed micro-hardness testing according to ASTM E34, FESEM imaging to study microstructure and surface details, and EBSD analysis to examine grain orientation, texture, and boundaries. This methodology is advanced and highly detailed because it combines additive manufacturing, metallurgical testing, and crystallographic analysis to understand how dissimilar metals behave during overlapping weld bit formation. If we compare both studies, they share the same general goal, improving and understanding welding process, but they use very different approaches. The first article used a traditional TIG welding technique on low-carbon steel, focusing on how flux composition changes mechanical strength. Meanwhile, the second article used a robotic WAAM GMT additive manufacturing system to weld two different metals, focusing more on microstructural evaluation and paste analysis. Both methodologies are well organized, precise and scientific, demonstrating two different but complementary ways of improving welding technology. That's all from me. Thank you for your attention.